Okay, this is the Math Models Unit 1 Lesson 6 video. I'm going to just talk through some of the main ideas of this lesson and do a few examples, and then there are quite a few for you to do on your own on this one. So this is an expansion of the previous lesson. Now we're focusing in on functions, and we're talking about what exactly a function looks like and how it works. And really, the best way to think of a function is kind of as like a machine that takes in one number, does something, and then results in some other number. And so you see here at the top of the page an example of how that works. You could have, for instance, a function that is y equals 3x plus 5. And these numbers would be the domain. So these are the numbers we're going to put in to the machine. The machine is going to multiply the number times 3, it's going to add 5, and it's going to end up with a new answer. So looking at this, you can see how they worked it out. If the domain value is -1, then we do 3 times -1 plus 5. That's -3 plus 5 is 2. And so then the ordered pair that comes from that one is -1, 2. And then there's my ordered pair. And we keep going. 3 times 0 is 0 plus 5 is 5. 0, 5. 3 times 1, which is the domain here, 3 times 1 plus 5 is 8, so 1, 8. So that's basically how a function works. So that's one aspect of what they're going to have you do. They're going to give you a list of domain values. They're going to give you the range, or in other words, they're going to give you the function rule, and then you're going to get the resulting values for those. But before we get into that, we should talk really quickly about, in general, ideas around domain and range, and also the terminology of independent and dependent variables. So they're going to give us all sorts of different kinds of examples of functions. Some are going to be things that might be like a real life example, and it's important that we're able to read those types of things and understand what is the dependent and independent quantities or variables in that situation. So I'm actually going to skip those first questions. We'll come back to those in a minute. But what I mean by that is they're going to have some questions here. Select the independent and dependent variable for each description. So the first thing that needs to be said, and I said this in the last video, is the first thing you need to know, of course, is that x is always, always, always the independent quantity. And y is always, always, always the dependent quantity. So those are always reliable. You can always know that these two things are going to be true. After that, or beyond that, you're going to have to do some thinking, and you're going to have to figure out, based on the example or whatever the way that the problem is worded, what is the independent and dependent quantity. So remember, the independent quantity is the thing that comes first in the relationship. It might be something to do with time. It might be something to do with how many times you did something. And here, like for instance, number 7, total wages based on hours worked. Based on or determined by are great examples, words or key phrases that are telling you what is independent. If total wages are based on hours worked, then hours worked is independent, and total wages is dependent on the hours worked. So based on is another way of saying that total wages is dependent on hours worked. Therefore, total wages is dependent, hours worked independent. So you'll just have to use your common sense and just do your best of ability to read those phrases, read those sentences, and determine what fits in which category. That's going to be a lot of those types of questions. Okay, then they're going to have us determine if a rule fits a already stated relationship. So for instance, and I'm just going to grab this and I'm going to move this over to the other screen so I can show you how this is going to work. All right, so I'm going to go ahead and draw on this. All right, so this is the example from the lesson. We've got these different function rules, and we're saying which one of these explains how to get from the domain to the range in this list of pairs. So in other words, if I put a 1 into these x's over here, which one of them will give me the correct y values? So it's pretty straightforward sometimes. Like for instance, the first one here, x plus 4, is pretty easy. We can just say, okay, 1 plus 4 equals 5. That works. 2 plus 4 equals 6. That does not match what we have for 2 in our table. Therefore, that is not the correct answer. So we stop and we start over on the next one. 4 times 1, that's using the next one, equals 4. Already, that doesn't match the answer for that, so we know that one can't be right either. So then we go to the next one. So you see, a lot of times you can eliminate these pretty quickly as you go. So then we have one of these two. So we'll start with 5x minus 4. So that's going to be 5 times 1 minus 4. 5 times 1 is 5, minus 4 is 1. That is not 5. So that cannot be the right answer. So pretty sure that's not it either, but let's check this last one. Notice I didn't even have to do them all. As soon as it's wrong, it's wrong. 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. That checks out. Then we move on to 2. 2 times, sorry about that, 3 times 2 plus 2. 6 plus 2 equals 8. That checks out. Move on to the next one. 3 times 3 plus 2 is 9 plus 2 equals 11, and that checks out. So then that last one has to be the answer. And so that's what you're going to do for all of these. You're going to take the x values, you're going to put them in to each one of these until you find the one that gives you all the correct values for y. So that's what you're going to do for number 1, number 2, number 3, number 4. We've already talked about 5, 6, 7, 8, 9, and 10. And then we get to number 11. Here, they're going to give you the domain, and they're going to give you the range or the rule. And then you have to correctly work out each range value. So if you look at the answer choices, you can see you've got individual values, -2, 1, 0, and then you've got ordered pairs. So just to be clear, all of the individual values go under the range, and all the ordered pairs go under the ordered pairs. So if I was doing this problem, for instance, I would start by taking -2 and putting it into this equation right here. So -2 minus 2, let's move myself down, and -2 plus 1. -2 minus 2 is -4. -2 plus 1 is -1. And -4 times -1 is 4. Feel free to use a calculator for any of those calculations, but they are pretty basic. So then I see that I get a 4. So I go look, I see 4 is one of the answers. And then the ordered pair is going to be, you can see right there, -2, 4. So I go here, -2, 4. So then I go to my next one. I would definitely be keeping an extra sheet of paper nearby for this. Again, -1 minus 2, -1 plus 1. I'm plugging -1 into the range. That's -3 times 0 equals 0. So we go over here, we choose 0, and then we choose -1, 0 as our ordered pair. you should be able to do the rest of those without much trouble. So you just plug in the domain into this range, find the answer, and then find the ordered pair that matches the domain and range combination. Same thing with number 12. Don't let this intimidate you. 1 divided by whatever the domain is, and then find the ordered pair. Same thing with number 13. Negative 2x minus 1 with a domain of negative 2, negative 1, 0, 1, and 2. This is a lot of busy work. I'll totally admit that, but just be careful. I would definitely show your work so we can look for mistakes if you make them. But that is it for this lesson.